Hello and welcome to the Bio360 podcast. In this episode, we are going to explore my favorite topic, water, once again. We are going to shed some light, pun intended, on how light interacts with water. My today's guest has developed a method to measure disease through the spectrum of infrared light that is partially absorbed by the water in our bodies. She's a world-leading water scientist and PhD in engineering. Please welcome with me, Professor Roumiana Tsenkova. Hello, Roumiana.
Hi, hello. Good morning.
Good morning. I'm very glad that you're here and we can dive deep into what you're going to bring to us today. Maybe before we're going to start, can you tell something about yourself?
I work at Kobe University as a professor of biomeasurements technology in Japan. And we developed in more than 10 years ago a new science called Aquaphotomics, which is complementary omics science to the rest of omics ones, like genomics, proteomics, metabolomics, which are following single disciplines. And I call them like vertical science, reductionist approach. But aquaphotomics is a complementary one, which uses the fact that water works as a collective mirror of matter and energy. And everything is reflected by the water. We know that when it comes to visible light, but the light that we use in my lab is invisible next to the visible, though, called near infrared. This is the infrared light, which is right next to the visible. And what is special about this light is that it gets absorbed by the water, but not fully, just enough to get the signal out of the water. So this is what I'm teaching. I'm a professor at working with students, developing this further the science. But actually, I started as with diagnosis of disease in mammary gland in dairy cows. So I started from milk, actually.
Okay.
Yes.
Okay. So you have just told us that many approaches to science are like reductionistic. You said, meaning that people looking at like one special thing, they pick out something like whatever, vitamin D or magnesium, and look at this,
Yes.
and then talk about this forever, and writing books about this. So, and you say like your approach is complementary, meaning like that is on top of all the other reductionist approaches, or what do you mean by that?
No. My image of this is like all reductionist approach sciences are vertical, and aquaphotomics is horizontal.
Okay.
Like a bouquet, it embraces all of them because as water is an environment, is milieu. I mean, it's everything's happening in the water. So 70% of us is water. And 70% on Earth is water, and maybe 70% in space is water. So we are still wondering if there is water in space, but there is definitely.
Ah, really?
So, yeah, and you can easily understand that by looking at the spectra, at the water spectrum, and the spectrum of the sunlight. The light that comes, half of the sunlight is near infrared, by the way, and something that we still don't understand why half. It definitely has its role, its function, and it is all related to water. What we with our research following and trying to explain, understand, etc.
Okay. How much of you said half of the sunlight is near infrared. Like, how much does reach actually us? Because we have an atmosphere and everything.
Yes, you're absolutely right. But still, half of the sunlight that reaches us is infrared light.
It's also infrared light, okay.
Yes. It gets absorbed, really. It gets absorbed by the water in the atmosphere, by the carbon dioxide, by oxygen. But still, the sunlight that reaches the sea level, half of it is still near infrared. But you can very nicely see the curvature of the spectrum of the sunlight by the water and oxygen, and you can see very nicely, of course, where the water in atmosphere is.
Okay.
So the spectra is very interesting to read the spectra.
Okay. Yeah. So yeah, the water absorbs the infrared light. We are already like deep into the topic, and actually I've asked you about yourself, and you told me something about the topic we're going to talk. So you're deep into that. Apparently that is your life, and really appreciate that. So. Let's just start all over again and just start from the beginning. Maybe could you just like in less than a minute just summarize what your work is about and what we're going to learn in this podcast?
Probably we're going to learn that number one, water is the only substance on Earth that absorbs any kind of energy. So you imagine the electromagnetic spectrum, and we call it light, and X-ray, from X-ray to radio waves, everything is light, and water absorbs all these energies. There is no other molecule on Earth that absorbs all energy. So, which means that water itself is a collective substance of different elements in a way. Number one, so we're going to learn how our bodies absorb, being 70%, nearly 70% water, how our bodies absorb sunlight, and what we can learn if we can analyze this light. So analyzing light means seeing how different energies, light with different energies, are absorbed by water.
Meaning that water reflects everything that is, and so we can find basically everything.
Yes.
As a signature,
Hello?
I mean.
Yes, exactly. You use the word that I'm using very often. The spectrum, our spectrum, is our signature, because what it absorbs reflects the light altogether, but we can measure all. We can measure light absorbance, we can measure transmittance, reflection. Of course, usually we work with absorbance, how much light is absorbed by the water. But the near-infrared light, the good news about near-infrared light is that it's not fully absorbed by the water, but partially. So the non-absorbed light comes out and we can measure it. So imagine you have a an infrared light goes to your body. It does not get fully absorbed. Partially it gets out. And then we can separate this light in different energies. And this is how we get the spectrum and the curvature, the signature of the body. And the signature of the body is unique for every of us. And the signature gets different when we get sick, when we get in a good mood, etc. So it's a collective biomarker. I call it integrative biomarker.
Okay.
Because it has lots of information. Yeah.
Okay, so I want to come back to that later at a later point.
Yes.
Maybe just start explaining your work, like what is it actually that you're doing? Like how do you measure the infrared light, and what is your approach? What is your take on light and health?
What we started with was we wanted to understand why we cannot make a good yogurt out of every milk. So it came out that a sick cow produces some milk that cannot make a good yogurt and good cheese. So, and coming back to answering the question why, it came out that the cow is sick. And so how we understood that by illuminating near-infrared light through the milk and getting back the spectrum of the milk, which means different energy, the amplitude, the rate of absorbance of different energies of near-infrared light coming out of the milk. So we can analyze this with spectrophotometer. It is the instrument that we use. And the signature of the milk was telling us which milk is coming from mastitic cow, which means a cow with mammary gland inflammation, and which milk is coming from a healthy cow. And
So by spectrophotometry.
Yes.
Spectrophotometry. You could tell which cow actually has a disease or not.
Exactly.
Okay.
Yes. But then later on, we figured out that the difference is the immense difference in the signature comes from the specific water absorbances. So it's not that much in. You could have absolutely the same milk components like milk fat and protein and lactose, but the water molecular system is changed in a sick cow. So that was eye-opening. That was the first idea to start looking at the water and understanding what water exactly is. It's not just H2O, one single molecule. It is a system of molecules that are like soldiers, and they do different functions depending on how they organize themselves.
Okay, so there is a certain quality of the water that you found out, and could you just define that a little bit? Because we have a lot of conceptions and ideas, and there's so much unclear about water in general. How would you define quality of water?
Now, the question about quality of water probably has a few directions. So I will pick one. When you say quality of water or water quality, the understanding at the moment is what molecules do you have in the water. And people that work on water quality are working with everything but water. So they try to measure toxins in the water. They try to analyze small molecules, and it takes lots of time and of course, funding.
Oh yeah, but, I'm asking way beyond that.
Yes. Now, what we can see with the light is a more systematic way, more complex way. We could see the whole spectrum of water, which tells us if the water has abnormalities. I mean, just one word. If the water, because with all the devices we have now, with all the computers and the big data, etc., we can store information about the water that is good for health, and water that is good to drink, and water that is not. And by the signature of the water, we can identify and just have a very fast quality evaluation of the water. In another way, we're talking about quality of water. We can also read and understand if the water has a lot of stored energy inside, like hydrogen bonds, the bonds between water molecules. or water has, I call it, is more working like has water clusters with hydroxylated water clusters with charged water clusters. Charged means with electric potential, which means that they easily interact with other molecules in the system and actually play a very important role of conductor in the biological system, in aqueous systems. And this is how the water quality and where the water quality comes from.
From the electric potential of restructuring and being in constant
movement.
Yeah, movement and reaction, being reaction friendly to everything that is.
And interaction with other molecules, yes.
Yeah,
yes.
Okay. Yeah, I think that's one of the key points of water anyway, that you can't really you just can't put your finger on it and say like this is water. It just, the moment you do it, it has already changed. Is that true?
Exactly. Yes. Water is a beautiful example of how everything changes on Earth. And there is, and people in spectroscopy usually want to have always the same spectrum as a criteria for a good instrument. And this is not the case with the water. You will never get the same spectrum. And this is the beauty of it.
Okay.
I mean, what is
so
changing?
It drives the scientists mad.
Well, if you understand water, no, it makes you happy because
it makes you happy. Yeah.
The changes bring you information. So this is a big thing, and a very important step in science.
Yeah.
Yes.
So you said like, okay, water absorbs everything. That's including EMF, right?
Yes.
Yeah, everything is everything. Just wanted to point that out, that our electromagnetic fields, like from 5G and whatever is coming up, and GPS and everything we have, is also absorbed by the water everywhere on Earth and in our bodies, in our brain, in our eyes, and everywhere it is.
Yes, a very important point.
Yeah.
Our eyes are 95% water. And we have to be aware of this. And our brain is more than 80% of water, 83%. And water is easily influenced by very weak perturbation, even. And water is changed not by... Of course, it is changed by strong perturbation, but it's even more changed by a very weak perturbation. So you made a wonderful point. Yes, electromagnetic field with all these cell phones that we are walking with and sleeping with are influencing the water in our bodies.
Yeah, I just had a thought. Maybe 15 years ago, I mentioned that in my podcast with Jared Pollack. Also, I've read books from a German guy that nobody knows outside of Germany. He's called Friedrich Hachenay, and he predicted the false phase of water 15 years ago. It's literally standing in his book. He says like there must be a false phase of water, and its nature will be electric. And so just had that thought. He said like if you speak something, a vowel or something, there's a word that forms a crystal, and if you actually exhale or speak that word to a very cold window, then you can see the formation of crystals. And animals don't have that. I've actually never tested that, but that meaning like without words, we're structuring the water in a way maybe. And so in a conversation, the other person is actually inhaling that. You know, you're in that kind of field of words that form a certain geometric structure in the water. And I just wanted to point that out because whether it's true or not, but just to get that idea, how fine and how well woven all that is. And now we're coming with EMF and just like, you know, with pulsed electromagnetic fields, and just like you just imagine what it does to this special quality that we actually have.
Yes. Now it is. I want to be very logical, and maybe if we can all follow this logic, we will understand. light, which means the electromagnetic field, even in a very low intensity, forms so-called fourth phase of water. And now we know that our bodies are full of water, and we absorb light every second. Light in terms of electromagnetic field. So when we say EMF, it means light. So it means that EMF makes fourth phase in our bodies. There's no doubt. So it means that EMF changes our water signature of each of us and all living systems and all aqua systems. So there are changes caused by weak electromagnetic signals. There is no doubt.
Okay,
sorry. We can measure it. We can. It is not like hypothesis. With aquaphotomics, with spectroscopy, with the method that we develop, we can measure and we can repeat our measurements. They are consistent, and everybody can repeat them. So, and this is the power of the technology.
Okay, so for the listeners, I want to explain that light and EMF is basically the same thing. It's just different frequencies. It's all electromagnetic radiation.
But what I was saying was that for sure, because the rest of the electromagnetic field, like radio frequencies and X-ray and UV, is absorbed by the water, and once water absorbs something, it changes immediately. So we change our signature, our water signature, with whatever electromagnetic field radiation is around us. And in another way, when you mentioned a little bit about the communication between people, and it is very easy. You have 70% water that absorbs light, but it's not fully absorbed. So partially it comes out of your body. So all the information about your body is around you, and it's absorbed by other people around you. So it is easy to understand the communication by light and driven by water.
Oh yeah, sure, and because that light has a certain signature, like which is like
exactly
not only different from person to person, but it's different from nanosecond to nanosecond actually. So that explains a lot, like how we can actually feel things about the other person, and or have a sympathy or not. Is this biophotons? Is this like kind of comparable to the work of Fritz Albert Popp?
Yes, because water absorbs and emits light. It does altogether. But it's not only the emission of the water. What I said, because water does not absorb, imagine light comes into the body. If water absorbs all of this infrared light, then you don't get any signal out, like unabsorbed light, right?
Yeah.
But water partially absorbs. So let's say it will absorb like 90%, and 10% will be not absorbed, which means that it's out of your body, and it forms your signature. It's not emitted light. It is just a non-absorbed light that is information. This is what we can measure. So we have a device that you can measure the spectrum of your body with sending full spectrum of light, like 100% of light at every frequency, every energy. And then your body absorbs each of the energies in a different way. What is not absorbed come back to the photosensor. And the photosensor tells you how much light has been absorbed. So this is the information that tells you what is your signature.
Okay. So the water is not emitting the light by itself; it's just reflecting it. It absorbs something and reflects the rest, right?
Yeah, it does both. But emitted light is on the top of non-absorbed light, in a way. So you have both emitted light coming, because emitted light also is light at different frequencies. So you have a light that is not absorbed, and on the top of it is light that emitted from the water.
All right, got it. So, Roumiana, I would like to take the opportunity to separate the podcast at this point. And
yes.
Thank you very much for being here today. And we're going to continue in the next episode. Thank you.
Okay, thank you.
Bye.
Bye.